Okay, welcome back, everyone. Coming up next, we have continuous reliability. How? And it will be given by Ana Margarita. She is currently working as a senior chaos engineer at Gremlin, and here she'll be talking about how to use Captain as CNCF sandbox project to operate your cloud applications, and of course, to get the most out of it. Is that correct, Ana?
Yes, definitely going to be talking about everything that we all love. How is it that we can keep our systems live, and especially as we're scaling?
Cool. If you're ready, you can start.
Perfect. Thank you very much. Well, welcome everyone to my talk. I'm very excited to have you all here as attendees. Feel free to post any questions as I go along. I have it open here and I'm going to try to pay attention to it. If not, I'm going to leave a few minutes at the end. But yes, I'm very excited to talk about reliability and how is it that we can really push forward the model of having an organization always think about reliability early on, but to also make sure that we're going back to that site reliability engineering principle about automation and standardization. I'm sure that I don't have to repeat this, but we all know that we're working on systems that are very fragile. We know that this is everything that a lot of folks are relying on now as we're in a pandemic. We're using this to get our shopping, to get around, to make sure that we stay in contact with our friends. And of course, in our work environments, it's everything, our virtual conferences, our Zoom calls for stand up, doing our offsites on all these collaboration tools. But we need to make sure that we continue thinking of how is it that we can continue to innovate without having as much failure, because customers matter. And we all know that we've seen so much change happen in the way that we operate our systems. When we talk about our legacy systems, we think about monoliths living on prem, where we have hundreds of servers on a rack that we need to manage. But this is only one service. Things are very much intertwined, but we don't have to think about all these other services that other engineers have idea on. And of course, we shifted left and we started to re-architect a lot of our applications. And that allows for us to get to where we are now. We saw the DevOps movements happen. We saw site reliability engineering become a hot topic and a whole field where we're all working on now. And where we're here, we now have constantly releases where we want to make sure that we're thinking about the reliability of each one, but that also comes with our microservices. We saw that maybe when we moved from the monolith to our microservices, we decoupled it to maybe 50 microservices. Or maybe you think that number's too high and you're like, wait, no, we only have 5. Like, what are you talking about? Well, you also get a chance to see large organizations that end up having 500, 1,000. And that's a lot of things to manage. And especially when we're running them at scale, when everything is getting more complex and distributed. And that's the thing, we've come a long way and we don't ever want to minimize that. But we also need to understand that operating these systems, keeping them up, thinking about our customers is really, really hard. We now have these really weird, complex failures that have a lot of things intertwined to them. And then, as site reliability engineers, that we have to debug all those things, we still find ourselves maybe not having the right observability or view into what's going on. We also find that a lot of this is manual work. We have to think about how is it that we can try to mitigate this incident. And with that, it comes a lot of playbooks and run books and running shell scripts and having that remediation steps. And that leads us to maybe feeling like this little graphic, yeah, this is fine. And we're the ones that are on call. So until when is this too much? At what point are we going to burn out by pager fatigue or just by so much debugging and having to make sure that our service teams and developers really start caring about reliability? And of course, when we talk about this pandemic, the this is fine emoji just resonates so much more with everyone. We have so many more users on the internet right now. And what does that mean? Where is it that we can take a lot of the learnings that we've had? Well, this is where my talk is comes in. How is it that we can really get to continuous reliability? Well, one of the things that I think about is that the site reliability engineering model really taught us some awesome things. We got a chance to learn that automation helps us. We also know that defining reliability goals and guidelines for our developers and folks in our organization really helps everyone align, and we have that standardization around everything. And when we continue reading those principles and hearing about organizations that really grasp this site reliability engineering model, we know that experimentation and a lot of thinking about how things can break, whether it's thinking about feature flags or failure injection, as such as chaos engineering, we know that those things can really help push us forward to make sure that we're not rolling back to failures that our systems have had, or that when we're making our architectures and systems more complex, we are not going to encounter as many new failures. And that's what my talk is going to be about today. Automation and standardization and experimentation get really packaged up for us to think about this as we do everything, and we think about the developers also grasping this model. But before I dive into Captain, I wanted to take a moment to introduce myself. As I said earlier, my name is Ana Margarita Medina, and I am a senior chaos engineer at Gremlin. I've been at Gremlin now for 3 years, and it's been super fun to get a chance to do more chaos engineering, work with our customers on community, and thinking about ways that they can break their Kubernetes clusters, their DynamoDB implementations, their Redis. And I didn't just get started with chaos engineering as I came on to Gremlin. I got a chance to join Uber as a site reliability engineer, and I did that by joining also their chaos engineering team. So I was diving deep into the fundamentals of SRE and chaos engineering around the same time, which really got a chance for my brain to grasp how systems and backends and on-call and keeping these large-scale applications at scale reliable. So I mentioned that I learned a lot of systems in that job, and that's because prior to that, I have done all the other developer stuff. And I was that developer that was like, well, it works on my machine. So yes, let me just throw it over here. And it's now your problem, ops. And a lot of that came from me being a front end developer, later transitioning to back end, doing mobile for iOS and Android. And I never really had to think too much about where is it that my code is running on if I am just throwing it to managed services. So that really got a chance for me to start thinking about, well, I know that persona of the person that's like, I don't have to be on call. I don't have to care about reliability as much. But now, as I've done a lot of that on call and really helping teams think about reliability, I'm like, okay, no, we really have to get developers to carry those pagers, to feel the pain. And if there's tooling that can really make it easy for them to think about those things, that's even better. And some of the things that really matter to me are diversity in tech and mental health. And because we're at a tech conference, I always have to make sure to call out that I am a proud Latina. I was born and raised in Costa Rica, and my parents are from Nicaragua. Representation really matters. And if you can't see it, you can't be it. So shout out to a lot of those folks that feel underrepresented in this space. You belong here, and don't let anyone ever tell you differently. So going back to this continuous reliability talk, we have automation, we have standardization, we have experimentation. And here comes Captain. Captain is a CNCF sandbox project that has a whole bunch of maintainers around the globe. This is a project that got kickstarted around 2 years ago by folks over at Dynatrace as they worked in this space and realized that a lot of the teams are just suffering from trying to tie in what they see in their monitoring observability tools and their incidents and what is actually happening within their organizations. So Captain is a cloud native application lifestyle orchestration that gets a chance to package a few things for us. When we say that it has observability dashboards and alerting, is that it has an automated way for it to actually configure those tools by Captain. And it also has a chance for you to get customizable dashboards just out of the box, and it leverages tools like Prometheus and, of course, Dynatrace. And we also have a chance to think more advanced and really set up those alerts, but they're just not alerts. They're actually set up by following those site reliability engineering things that we've learned, as such as service level objectives. And we have all those things to be defined as code, which is really, really awesome. We know that infrastructure as code has really helped push our industry forward. So that is where standardization really comes in. Captain really enables you to have standardization around service level indicators and service level objectives. You get to define that per service and per stage. So you know that now we have as many tools in our ecosystem of our organizations, and all these tools really want us to define SLOs in them. Captain allows for you to just have one way to define them across the board. And this really lets you standardize that across your organization. And if you want to learn a little bit more about how this is done, you can also see other chats that just happened this week at SLO Conf by Jürgen and Andreas Grabner from Dynatrace. And the other thing with this that I mentioned is that if we can really get developers thinking about reliability early on, this is how we are going to get better. So by implementing those service level objectives in the pipelines, we now get to enable developers to see how their code, how their improvements, the features that they're working on really impact reliability. Reliability as defined as those service level objectives. And those service level objectives actually end up being a gatekeeper. So you won't be able to deploy to staging if your features are actually making response time really high that would actually end up reaching later on down the pipeline those service level agreements with our customers. So it's really about bringing those things a lot earlier to the developer. And that's something that is being called as test-driven operations with service level objectives. So now we're building in those service level objectives into the pipeline to act as gatekeepers. And not only are you having those guidelines, you can also define remediation actions. So when a lot of those issues end up being that maybe it's your Kubernetes cluster running out of resources, maybe that's when the remediation is making sure that you're actually auto scaling. And if auto scaling is taking a while, maybe making sure that there's a cache in, or just defining other things to route traffic. Maybe it's enabling a feature flag. Maybe it's actually shutting off a service that is creating all this busy traffic. So this really allows for those remediation actions to be automated. They get executed for you. And then that service level objective gets revalidated. And I mentioned we have those objectives that get a chance to be defined in every single stage and within every single microservice. So that really allows for you to run those tests and make sure that your developers are still being able to develop and work on those features at a good pace, but that it's not happening in a way that things are getting more broken. And when you hear from the Captain team, there's a whole bunch of talks from the maintainers that really share insight on what really drove for them to develop this project and how is it that they've helped grow it. And a lot of it is that they asked around to the community of like, what is actually going on in the organization? And a lot of them were spending a lot of time building their own delivery platforms. And with that, it was very much of maintaining and the outages that happen within your CI/CD tooling, being able to just not have to spend as much time running all those manual tasks to keep these services up. And that's where a lot of the time went. running those manual steps and then getting a chance to build those manual steps to be better. And as I mentioned, how all of this comes together in making sure that we gate those deployments prior to them going to the next stage. And just to show a little bit of a diagram of what I'm going to show next is very much about having captain be deploying with helm, and then all of that gets processed by captain. So you're able to see where services you are deploying across your stages, how they are doing in terms of health status, and you are going to have those service level objectives reevaluated prior to anything getting promoted. Cool thing is that I also mentioned that you have that remediation that can happen for you. So that means that you have everything going on within captain. You are checking those service level objectives within captain, and if there is a breach, this actually creates an alert for you. Or if you're using Dynatrace, is going to be a problem, and it's able to run those remediation attacks. If everything worked out fine, you get a chance to go back to normal and that alert is gone, that problem is solved. And if not, is going to continue running through these steps. Or if there is no way that the steps are actually able to fix the issue, it's okay because this deployment didn't make it to the next stage. So now I'm going to give a little bit of a demo, a little bit of a different demo. The demo gods weren't with me, so my demo broke, but I have screenshots of everything I did. And if you're interested in getting a chance to see some of the screenshots and commands that I'm going to be running through right now, you can actually run through this at home as part of the tutorials.captain.sh page. And this is the full tour of implementing it with Dynatrace. So getting started with Captain is actually pretty easy. You install some CLI tools to get you up and running. With running this tutorial, you also have to configure Istio and have a cluster that's large enough to run 3 stages and get a chance to scale it too. So I am going to run through some commands, but there's also just a lot of steps that are in between that I'm not fully showing. But we're able to install Captain within that first command. Then we get a chance to create that project. And that demo environment that we're giving is that sock shop. And this is defined within the shipyard. This is what's going to be running in Captain for us to be able to organize what we're about to do. As we get a chance to deploy the sock shop, this shipyard has also defined the stages that we're going to be having within our pipeline. That, of course, is our mostly known as dev, staging, and production. Then we get a chance to onboard services. You get it, captain, shipyard. We now onboard a service to our shipyard, to our captain. And that's easy. We get a chance to define all of this within instructions in Captain. Most of this is just defined as YAML. So we now create the 2 services that we're onboarding, known as carts and carts database. Those things are now being seen as services within Captain, but there's nothing in them. So we get a chance to now trigger that delivery by just running these 2 commands. You want to run them separately so they don't crash with one another. We deploy the databases and we deploy the carts. And you get a chance to also tag them. So when you're having various iterations on this, the tags are really, really helpful. It helped me a lot in debugging. Then in the next screenshot, we get a chance to see how that delivery is actually progressing. We have it on dev, we have it on staging, we have it on production. We see that this is that continuous portion where they all cleared out green. This is just a standard deployment. This is just the first version of it. So we don't have as many things as defined. We get a chance to define those service level indicators. We define those objectives. And that allows for us to have better insight into our pipeline. That brings us to this portion where we have now seen what the cart service does. So I have it open on the right side where we have our dev environment at the top right corner. In that middle part, where is the other red box, we have our staging environment. And at last green box at the bottom right corner, that's our production environment. So we rolled out the second version of our application, which is tagged as version 2 in our deployment. We deploy that, but we see on the main screenshot of Captain that it's actually red in staging. And that is because the evaluation of this test and staging, where it gets a chance to just do a check on that service level objective, it's actually not passing. And it's awesome to see that when it's not passing, we actually didn't break production. So it's really getting that chance for the developer to see how is it that the changes that they're making, whether it's configuration or application code for features, how is that going to affect the whole budget of reliability for this service? And just to go back into that screenshot of how is it that it defines that service level objective, you get a chance to define all that within a YAML file. So at what percentage do you need to have a certain response time? And what is the pass criteria for this? You get a chance to define as many of the indicators as you want, whether it's response time, latency, throughput, and you then also give it a score. So if you're pulling in data from various different metrics, such as response time, load generator test, and also a chaos engineer experiment, they all can be weighted different scores and define that fail or pass portion of it. So now that we learned all that, the engineer is able to go back, put in some fixes into their application, and roll out the next version of their application. And when we see that rollout, we see that in Captain, it was able to pass through all the three stages of dev staging and production. And when it got to production, everything was pretty steady, pretty reliable. That was that continuous portion of us being able to make sure that we're thinking about reliability as a whole. And our application is now all green. They're all running on the same on the same versions of it. And how is it that that looks like as you look at the service as a whole, which is pretty neat because now you get a chance to take a step back and it's like, how is it that the service has been doing in terms of reliability in our staging environment? And you can see that histogram of the evaluation of it. So we saw that we were actually passing those tests on that first deployment of it. On the second deployment of it, we saw that it failed. And you can also see a chart of what that response time is through that histogram, which is also super neat because you're pulling in all these tools to have just one view of reliability. And lastly, those last two boxes of green, that was the last deployment that we just ran through. And that's where everything was able to keep that service level objective. That SLI was not breached. And Captain defines that as a pass on this evaluation test of the service level objective. And that's mostly the recap of Captain as a whole, but there's a lot more that Captain can do. And one of the amazing things that Captain allows for you to do is that piece of experimentation. We get a chance to inject chaos in the pipeline and really go into injecting failure and be proactive about the failures that can happen to your application. So there's two ways that I see for you to be able to run chaos engineering experiments on Captain. You can run this as a experiment test within every single stage, that it allows for you to make sure that prior to things getting deployed to the next stage, you are reliable. You're not drifting into past failures. You're not going to breach those reliability metrics that matter to your services. And then the other model of it is setting up that chaos stage, setting up one stage to do chaos engineering experiments prior to your services getting deployed out to production. And within those two models, there's another added benefit of using a tool like this that graphs it together, or just thinking about reliability in a more continuous manner, is that you can also do this alongside of performance testing. So when you're thinking about rolling out new features, preparing for that new launch day of your new service, for the new shoes that are coming out for your company, for the new banking feature that's rolling out, or just a whole new UI rehaul, how is it that this user load on your application is actually going to affect everything? So the question is, are the service level objectives still met? They're met. You promote to production. They're not met. You have identified a weakness. You now can go improve and repeat on it. And this is then going to run through that reevaluation model. There is some really cool stuff happening on the conversations and implementations of chaos engineering on Captain. And if you really want to see a little bit more of that on demo and in depth, back to that SLO conf that just happened this week, Jürgen got a chance to speak about evaluating application resilience with chaos engineering and service level objectives. This is that model of having a chaos stage before you get a chance to roll out to production, and how this is a rinse and repeat process for you to be continuous about it. And some of the key takeaways from a lot of my talks around building reliability is that you can't just build reliability overnight. You can't just build a new service and say, we just want a new 9. And you also can't just buy a new reliability tool and say, we're now 4 nines, 5 nines, we're about to hit that in the next month. Reliability does take a lot of practice. It takes your whole organization to care about reliability. And this is where a lot of that SRE mindset and thoughts come in, where you have to go into establishing that process, making sure you go and you automate it so you reduce that toil, and then you do things continuously to not regress into past failures that you have seen. And a lot of this comes into experimentations, defining those service level objectives, indicators, agreements, running those fire drills to execute failovers, to run through your runbooks. And you have to be continuous and be able to get all your leadership and engineer team mostly on the same page, that everyone is really trying to make your organization's reliability metrics a lot better. And with Captain, there's a whole bunch of awesome integrations that have been rolled out, whether it's with Helm, Argo, Jenkins, JMeter, Neoload, Litmus, Dynatrace, Grafana, Prometheus, and such. There's a whole bunch more that are coming along. And if you're interested, you should really check out the Captain community. I'm one of the advisory board members for Captain, and it's been awesome to see this project grow just in the last 6 months. But there's so much more coming that they're just getting started. So if you're curious on learning more, you can go to captain.sh, and it has all the resources from community office hours, tutorials, Twitter, webinars. You can also follow along on Twitter. You can go give the project a star on GitHub. There's a few tutorials to get started, some just taking 25 minutes, some taking 2 hours. And as I said, there's a lot of video content coming out by the Captain team. So head on over to YouTube and check out some of those things. I also want to get a chance to give you a chance to continue learning about reliability. So we want to offer you the free copy of Reducing Mean Time to Detection for Incidents. So you can head on over to gremlin.com/talk/WTF is SRE, and you can learn more about this topic. I would like to thank you very much for getting a chance to hear my talk around continuous reliability. I'm hoping to make this talk a lot better. So if you have any feedback or thoughts, I'll gladly appreciate them. And if you have any questions about reliability, Captain, chaos engineering, I'm always available on Twitter and LinkedIn. And if not, you can shoot me an email at anna@gremlin.com. Gracias.
Thank you. Really enjoyed it. We are a bit over time. If you have any questions, like Anna said, you can shoot them to her email or Twitter. Also here on Umbrella, you can start a meeting, then you cancel, then you can send text Umbrella as well. After this, we'll have a quiz on track 1. You have the opportunity to win some socks and awesome t-shirts and some other giveaways. And I think that's it. Leon, do you have anything?
Well, there's also the keynote, the keynote talk by Alyssa Miller on track 1. So we'll be back on track 2 after Okay, so the plan is quiz, keynote talk, round tables. So we'll be back here at 8:30 p.m. if you're in Europe, except the UK. For them, it's 7:30, and I have no idea. What time is it for you now, Anna? In
It's
California?
9:45 in the morning in California. So
Okay, so it would be 11:30 in California then.
Pacific time.
Thank you so much, Anna, for your time and for your talk. It was very fascinating.
Thank you all very much for having me. See you all online and stay safe.